So we're looking at how to find the term, emphasis on the term, containing a special exponent. And an exponent is basically just what? A power on x. It could also be on any other variable they would want, but under binomial theorem, it's basically x. So we'll understand this with an example. So let's say we've been told to determine the term that contains 1 over x to the power 6 in the binomial expansion. Okay, say we have a binomial expansion of, let's say we have something as 2 over x to the power 3 plus 3x squared, then the root of this is to the power 7. Alright, so since we've been told to determine the term, we should be mindful that the only thing we're interested in is the term that contains 1 over x to the power 6 in its expansion. There are several expansions that will have maybe x to the power 2, x to the power 3, x to the power whatever it may be. So now these expansions belong to a particular term value. So you want to determine the term that will contain a particular given x variable with a certain power. That is, if we're being given a binomial expansion of some power, which is n. And in this case, we have 7. So given 2 over x cubed plus 3x squared to the power 7, all we have to do to determine the term is to use basically a formula where we say t to the k, or t sub k plus 1 is equal to n choose k times a to the n minus k times b to the k. So I'll explain clearly how this one works. Now, there are certain binomial expansions that are simple to follow out and easily determine the position of the term that will contain such a value that might be given in question. But if you look here, we're having a power of 7, which is significantly big. It's too big. So the best thing to do is to use the term equation. So in the term equation, we have basically some things that might not make sense now, but be mindful that this term equation can as well be written as t sub k plus 1 is equal to n k, then a to the n minus k times b to the k. So we have these two that we can use. So we need to be mindful that t sub k plus 1 is simply just t sub k plus 1 being equivalent to t, let me say k plus 1 rather, or k plus first term. So t sub k plus 1 is equal to k plus the first term, which is the value of k that you find plus the first term to determine the term you need in question. Then a is basically the first term you have in the parentheses, where we have star representing the parentheses. So b is the second term. And then the other thing we should know is that n will always represent the power. Now, with this said, let us try by all means to solve the question that we have. So basically, since we're having n choose k, or n choose k, which will always symbolize the coefficient of a particular term, we can be mindful that every time we're solving for a term, we first have to follow basic steps. And the first step is basically to solve for k. So solve for k. So now, how do you solve for k? You go back to the term equation. Remember, t in which k plus 1 or plus the first term is equivalent to n choose k times a to the n minus k times b to the k. Now, this part here represents the term that you want in question. And this part here shows you what you end up having on that particular term. So this is the coefficient, which is n choose k, times the variables that will be present on that particular term. If it's the first term, to have a particular variable. Let's say, for instance, you have 2xy. This 2 is obtained from n choose k. Then this x is the a in question, and the b is the y in the term equation. So that is just a simple way of understanding this. So when it comes to solving this, basically we are having the question, which is 2 over x to the power 3 plus 3x squared then to the power 7. There are basic things you have to put in consideration. So consider these aspects. The first aspect is that you have to forget about all the coefficients of x. So forget about the numbers, or rather we can say the coefficients. Not just that, you should also ignore negatives and assume positive. Then not only that, what you should do other than that is also ignore. Since we're ignoring the coefficients, we're going to also ignore n choose k in our term equation. So which means that in actual sense, the term equation will not actually possess the n choose k. But in question, if we start by considering the aspects which are not to bear in this question, let us ignore the numbers of the coefficient, which means that we'll have 1 over x to the power 3 plus x squared then to the power 7. This is us ignoring what? The coefficient. We don't have to remove the positive number there because we are ignoring the negatives, then assume all positives. So we have to show the positive there. Now, after we do that, remember we're having in question 1 over x to the power 3. That is if we ignore the coefficients, then x squared then to the power 7. Now, with this in mind, we can now apply or remember that the term equation, which is 10 t sub k plus 1, is equal to n choose k, then a to the n minus k plus b to the k. Since we're forgetting about the coefficients, you can also ignore this and say the term equation, which is t sub k plus 1, is equal to a to the n minus k times b to the k. So using this, let us now see to it that we solve for k. So let us try and look for a to the n minus k times b to the k. Now, since we have a to be 1 over x to the power 3 to the power n, remember n is equal to the power, of which the power here is what? 7. So we have 1 over x to the power 3, then we have 7 minus k times the value of b is x squared to the power k. So we can distribute this power. Remember, whenever you have a over b to the power n, it will always be a to the n over b to the n. So if we distribute this power, remember we're only interested in the x terms. We can't start putting this x minus k to the 1. It's not really important when it comes to the 1. So basically we're writing it as, because if we want to avoid having those inconveniences, we can say this is basically x to the minus 3, then 7 minus k, then times x to the power 2, then multiplied by k. This is basically what we're having. So with this in mind, what we can do basically is now remember that if we have the same bases, let's say a to the n times a to the m, this is equal to a to the n plus m. So we can apply this particular aspect. So since these are the same bases, we have x to the, remember the other point is that if you have a to the n, then m, this is basically a to the n times m. So we have negative x to the minus 3 times 7 minus k. Then this will be plus the other particular term, which is this one, having 2 times what? K. Now, for the sake of people who might not understand this point, what I'm really trying to say is this. Since we have this portion here, this portion will be x to the minus 3 times 7 minus k. Then times the second portion, which will have x to the power 2 times what? K. So this is x to the power negative. If you say negative 3 times this and that, you have negative 21, then plus 3k times x to the power 2k. So you have x to the power, remember now same bases, you now have to apply this concept and add the powers to be negative 21 plus 3k plus 2k. So you have x being equal to, I can push a negative inside and assume first these positives and say 3k plus 2k is 5k minus 21. So this is basically the term. So we are having it as x to the power 5x minus 21. And this should equal to our term in question. Term in question. So be mindful that the term values from the equation that you're solving should always equal to the term in question. And the term in question is a point where we have 5x minus 21 is equal to, what they're saying is that determine the term that contains. So what it really contains is the term in question, or yeah, what it just contains in simple terms. And we're saying that it should contain 1 over what? X to the power 6, isn't it? So which means that this can be written in actually a better format. So you have x to the power 5x minus 21, and this is equal to x to the what? Minus 6. Same bases have equal powers, so this cancels out with that, and you have 5x minus 21 is equal to negative 6. 5x is equal to negative 6 plus, when this goes the other side, it becomes a plus 21. So you have 5x being equal to, this should be 15. Now remember, you're looking for x, not 5x. So 5x being equal to 15, you divide by 5, divide by 5. You have x being equal to 3. Now, this is the value of x, which is basically the value of k. I don't know why I'm always making the k be x. So this is actually k. Sorry about that for those who are following. Yeah, it's k. So these are all k's and not x's. Yeah, quite used solving these things. So this is a k value. So k is equal to negative what? 3. So do not get lost with the k confusion. So since k is equal to 3, remember that the term that is in question is always k plus 1. So this means that you have term 3 plus 1 is giving you term 4. So the term that contains 1 over x to the power 6 is basically term 4. So the final answer is the fourth term, like that. Okay, so this is the second problem. They're saying determine the term containing x to the minus 12 in the expansion, which is given to be 2x cubed minus 1 over x, and this is raised to the power of 20. So to find the term, we basically use the term equation where we say t sub k plus 1 is equal to n choose k times a to the n minus k times b to the k. Now basically, since there are a lot of things that we neglect when we're solving this, what we first have to do according to the steps is to solve for k. So now how do we do that? So we get what the term is equivalent to. So the term is equal to n choose k times a to the n minus k times b to the k. Now since we're having the expansion as 2x, rather just this to say minus as 1 over x and to the power 20, we can put in consideration that if we neglect the coefficients, which means that n choose k also goes, and here on star, then we won't have the 2, we just have x to the power 3. And also neglect the negatives and assume positive. Where there's negative, we have a plus, then 1 over x, and this is raised to the power of 20. So this 20 is basically, when you say data, it's actually the n value, which is 20. So a is the first term, so this is a, and b is the second term. So by solving for k, we just substitute and say a is x to the power 3, then n is 20 minus k times b is 1 over x, then to the power of k. Applying basic index laws, we'll have x to the power 3 times 20 minus k times, this can be written as, this point here can be written as x to the minus 1 times k. This is x, we multiply this by that, you get x to the power 60 minus 3k times x to the minus k. So we're having this part here. So since we're having x to the power 60 minus 3k, then times x to the power negative k, we can just apply the basic in this concept. And same bases, different powers, the same powers, provided you're multiplying, you add the powers. So it will be x to the power 60 minus 3k, then plus times positive and negative would be minus k. And this would be x to the power 60 minus 4k. So whatever that you find here should be equivalent or equated to what we want in question. So we want to look for the term containing x to the minus 12. So this is x to the power 60 minus 4k being equal to the term we want in question, which is x to the minus 12. So don't get confused if at all they give you in question to say 1 over x to the 12. You can always just convert this to x to the minus 12. It's just that in this case we've already been given as x to the minus 12. So it's basic knowledge. So we just cancel out the bases, because same bases have equal powers. So the powers should be equal. So I have 60 minus 4k being equal to negative 12. If I solve for k, this can go the other side and this can come this side, and I have 4k being equal to 60 plus 12. And then 4k is equal to 60 plus 12 is 72 divided by 4 divided by 4. I basically have k being equal to 18. Now be mindful, since we have been asked to say which term we want in question, we look for the term using t sub k plus 1, of which we now know that k is equal to 18. So we say t sub 18 plus 1, which means the term is the 19th term, because 18 plus 1 is 19. Therefore, it's the 19th term. So this concludes the end of this concept.